In this video, we'll learn to solve simple equations. These equations are given the name simple equations because it only takes one operation to solve them. For example, here we have x minus 9 equals 3. In solving this equation, what we're trying to do is find all values of x for which this equation is true. So you can think about it as filling in the blank for x. With an equation like this, we might be able to just look at it and guess what x should be. In fact, here, if we take 12 minus 9, we get 3, and that might be pretty easy to see. However, as equations become more and more complicated, we'll rely more and more on techniques to find out what x is. The technique we'll use here is the additive property of equality that says if I have an equation, I can add the same thing to both sides of that equation and still have a true statement. So, for example, if I add 9 to both sides of this equation, on the left, what that's going to do is the minus 9 will cancel with the plus 9, leaving me only with x. Whereas on the right, I'll have 3 plus 9, which will give me 12. So this technique of isolating x by adding 9 to both sides shows me what the answer is. In this example, we're supposed to solve each of the following equations for the variable. In both cases, we'll be able to use the additive property of equality to find the solution. We want to think about what's keeping the variable from being by itself on one side. In part A, we have that 9.8 is added to the variable. So to get s by itself, we're going to subtract 9.8 from both sides. On the left-hand side, that's going to leave us with s, and on the right-hand side, that will leave us with 3.2. So we know the solution is s equals 3.2. In part B, we have q minus 3 over 4 equals 7 over 8. 3 over 4 is being subtracted from q, and that's what keeps q from being by itself. And so we'll do the opposite. We'll add 3 over 4 to both sides. And then q is isolated. This gives us 7 over 8 plus 3 over 4. Now we need to simplify the right-hand side to find the value for q. To do this, we need a common denominator. The least common denominator here will be 8, so I need to take 2 over 2 and multiply the second fraction, obtaining an 8 in the denominator. This is going to give us q is equal to 7/8 plus, and then I have 3 times 2, so 6, over 4 times 2, which is 8. So now we'll know that q is equal to 7/8 plus 6/8, which gives us 13 over 8. In this example, we'll practice solving simple equations where there's a value multiplied by x, and we need to isolate x. So for example, in part A, we have 2x equals negative 6. X is multiplied by 2, and so in order to undo that operation on x, we need to divide both sides by 2. On the left, the 2 over 2 will cancel, leaving us with x. And on the right, we have negative 6 over 2, which gives us a negative value, and then 6 over 2 is 3. In part B, we have 1/3 y equals negative 11. We can think of this as 1/3 times y, or we could think of it as y divided by 3. In order to undo y divided by 3, we need to multiply both sides of this equation by 3. This will look like 3 times 1/3 y equals 3 times negative 11. But 3 times 1/3 cancels itself out and becomes 1. So on the left-hand side, we just have y, and on the right-hand side, we have 3 times negative 11, which will give us a negative value, and then 3 times 11 is 33. So we get negative 33 for y. Let's check for understanding. Work this one out on your own first, and then come back and check your solutions. In part A, we have 7 times x equals negative 49. To get x by itself, we need to divide by 7. And so we obtain x equals negative 49 over 7. But 7 times 7 equals 49, so this will simplify to negative 7 over 1. And so we'll have negative 7 as our answer. In part B, we have x minus 5 equals negative 6. This minus 5 is keeping x from being by itself. To get rid of it on the left-hand side, we'll add 5 to both sides. And that will give us x equals negative 6 plus 5, which is negative 1. In part C, we have 3/4 x equals 12. We know that to undo multiplying by 3/4, we would need to divide by 3/4 or multiply by the reciprocal of 3/4, which is 4/3. So I'm going to multiply both sides by 4/3. On the left-hand side, that's going to cancel the 4/3 and the 3/4, leaving us with x. And on the right-hand side, we'll have 4/3 times 12, which is 4 times 12/3. Now we can simplify that because 3 divides 12, we'll end up with 4/1, which leaves us with 4 times 4, which is 16/1. So we just get 16. In part D, we have 1/5 x equals 16/25. The opposite of division by 5, or multiplication by 1/5, is multiplication by 5. So we'll multiply both sides by 5. We'll obtain 5 times 1/5 x equals 5 times 16/25. On the left-hand side, the 5 and the 1/5 cancel, leaving us only with x. And on the right-hand side, we have 5 times 16/25. 5 divides 25, and so this will reduce to 1/5, and then we'll have just 16 divided by 5.